Module 1, Lessons 9, 10, and 11. We are now going to be dealing with our unknown angles, and we are going to start writing proofs with them. So let's start out with some vocabulary. A conditional statement, we have seen these in all of our postulates and theorems so far, is simply an if-then statement. Our hypothesis, or the requirement, is the part that goes with the if, and our conclusion, or result, is the part that goes with then. We have experience already with a converse, and a converse is simply where we exchange or switch our requirement and our result. We switch our if and then. Now, a word we haven't encountered yet is biconditional, and this is just a single true statement that combines our true conditional and the true converse. And we write our biconditional by joining both parts, our if and our then, with the phrase if and only if. So let's look at an example of this. Our conditional says if a point is a midpoint, then it divides a segment into two congruent segments. The converse takes our then and turns it into our if. A point divides a segment into two congruent segments. Then it is a midpoint. And so the biconditional is written as a point is a midpoint, no if or then on this, if and only if it divides a segment into two congruent segments. So there's no more if and then in a biconditional, and you recognize it by the if and only if, because the biconditional is true both forward and backward. We are going to use our conditional statements, our postulates and theorems, to write proofs. And a proof is simply a convincing argument that uses deductive reasoning. This is logic. Okay? Some review from algebra are properties of equality. Now, these first four you have seen and used multiple times for years now. The addition property of equality, subtraction property of equality, multiplication and division properties of equality. These are what let you solve equations. They let you add the same number to both sides of an equation, subtract the same number from both sides of an equation, multiply and divide both sides of an equation by the same number. As I told you before, geometry is the math that lets all of the other maths do math. So you recognize these. Now, one you may or may not have seen before, and it's one that we will use a lot, is the reflexive property of equality. And reflexive simply says that something equals itself. A equals A. So this is like saying 3 equals 3. Or the length of segment AB equals the length of segment AB. Or the measure of angle 4 equals the measure of angle 4. And you say, well, why would we need to do that? This is so much more powerful than you can imagine. We will use this more than you could ever imagine using this. What this does is it lets us say that something is equal to itself, which means we can use it in two places at one time. So we can use segment AB in figure 1, and we can use segment AB in figure 2, and it still retains the same length. And so this is extremely useful to us. Now, the symmetric property, we don't really use it much, but you should recognize it from algebra. It lets us switch the sides of an equation, and you may have used it to make something easier to read or easier to work with. It's not one of the big ones that we are going to be using. Now, the next two, though, the transitive property of equality and the substitution property, these are two we will use all the time, and these two are also kind of difficult to tell apart. The transitive property of equality, and you've seen this, I'm almost certain, says that if A equals B and B equals C, then A equals C. And you notice here that we have something repeating in both of them. And we simply cut out the middleman and say that A equals C. The substitution property says that if A equals B, then B can replace A in any expression. Now, the way to tell these apart, and I'm very generous because at the beginning here, it's kind of difficult to know which one to use. You'll get better with practice. The transitive property is used when you have two separate ideas. Each one could stand alone on its own. The substitution property, this is when, like, you've used this a lot. You're given x equals 3, you go to your equation and you find every x and you replace it, you substitute a 3 in there. And this is often used when we have numbers that are just replacing each other. Okay, so you'll get, like I said, you'll start to recognize this and get better at this as we go. We will talk more about it. The properties of congruence, these are big for us. This is kind of the geometry version of some of our properties of equality. And you will notice that once again, we have the reflexive property of congruence and the transitive property of congruence. The reflexive property of congruence says exactly the same thing, only this time we're not talking about lengths or measures, we're talking about figures, so segments and angles. Segment AB is congruent to segment AB. Angle A is congruent to angle A. So properties of equality deal with numbers. Properties of congruence deal with parts of figures. Now again, the symmetric property does exactly what it did before. It just lets us switch sides. And the transitive property of congruence does exactly what it did before, but this time we are again working with parts of figures. So if segment AB is congruent to segment CD and segment CD is congruent to segment EF, notice we have the repetition there. We can simply say that segment AB is congruent to segment EF. This works for angles and also even if they aren't next to each other. Okay, so you're looking for that repetition. And again, transitive property deals with when you have two separate ideas. These segments are congruent and these segments are congruent. It's not a simple substitution. We also have the distributive property. Okay, this should be an old friend from algebra, where if we have something times a quantity, A times the quantity B plus C, then We use our rainbow of sharing happiness, and we distribute, we multiply what's outside by everything inside. This also works, the distributive property is also when you are combining like terms. Combining like terms is kind of undistributing. So if we have 2x plus 3x, you know that it turns into 5x. But how come it turns into 5x? Well, you probably don't remember, but you should have been taught that you pull out what's common, the x, and then you add the coefficients, right? Because x is common to both. This is factoring. You should remember factoring. So we are adding our coefficients and then multiplying by our variable. So you can see the distributing in there. Combining like terms is the distributive property. Pretty nifty, huh? Lots of good algebraic properties of equality and properties of congruence and substitution property and distributive property to go along with our ever-growing list of definitions, postulates, and theorems. We are getting a very large toolbox here to do our proofs with. Now let's take a look at proofs. We said that a proof is a logical path to show why our conjecture is true. Conjecture is just an idea that we want to be true. We are going to be writing 2-column proofs, and the statements go on the left, and your justification, which is the reason, which will be a property, definition, postulate, or theorem, will go on the right. So let's look at, this is what it's going to look like here. You have a given and a prove. We are given information. It can either be written or marked on our diagram. Markings on a diagram are considered given. They are facts that we have available to us. And we want to prove something specific. And we just write them in 2 columns. Generally, you start with your given information. You don't have to. It may fit better somewhere else. And then you work your way through step by step, just like solving an equation for a variable, until you have proven what you were asked to prove. We are going to be using the ideal problem-solving method. Identify, define, explore, act, and look back. It is a very good way to help you write proofs. Now, in this proof, we are given that line A is parallel to line B, and we want to prove that angle 1 and angle 8 are supplementary. So I am going to start on my diagram. I'm going to mark what I'm given. I've got parallel lines. What do parallel lines mean to me? Parallel lines mean special angle pairs. I know that I am cut by a transversal. I know I've got special angle pairs. And I'm looking to prove that my angles are supplementary. We know that this means they're going to sum to 180 degrees. So we start looking at our diagram, and the defined portion is brainstorming. And we are going to write down and mark everything that we possibly can about our diagram. So first thing I see here is angle 1 and angle 5 are going to be congruent. And I know that's true because of my corresponding angle postulate. That's one of my special angle pairs. Anytime I have congruent angles or congruent segments, the definition of congruence allows me to say that their measures are equal or their lengths are equal. So these two always go together. Now, am I going to need all of that? I don't know, but it is available to use. That's what the define portion is about. Now, the next thing is I see linear pairs. We have angle 5 and angle 8 are a linear pair, and angle 8 and angle 7 are a linear pair. And why am I looking at linear pairs? Because I know they are supplementary. Right? They're linear pairs by definition of linear pair, and they are supplementary by our linear pair postulate. So those are options. What else do we have going on? Well, I see that angle 5 and angle 7 are vertical angles. So if those are congruent, oops, we need to change this. Angle 5 and angle 7, their measures are equal. That's simply definition of congruence. So those can go together. And that's pretty much all we have available to us, but that's quite a bit. Now we need to figure out how to relate angles 1 and 8. Well, who else relates with angle 8? I see angle 5 relates with angle 8. So I'm going to decide I probably don't need angle 7, so I can cross out my angles 8 and 7. And that means I'm probably not going to need my vertical angles theorem. So now I'm starting to pull out only the pieces that I'm going to need. So I'm going to start with 1 and 5 are congruent, and then I can say that my measures are equal. I have a definition of congruence. I also know that the measure of angle 5 plus the measure of angle 8 is 180 degrees because I'm aiming for that supplementary. And because 1 and 5 are essentially the same angle, I'm going to be able to look at substituting in 1 for 5. That's going to be how I'm going to be able to relate angles 1 and 8. I have to go through 5 to get there, but angle 1 and 5 are pretty much the same angle because they are congruent. So I can substitute them for each other. So let's look at, now that we have all of our ideas, which ones we're going to use, and how we're going to put it together, we can go on and write our proof. Look at all of this work that we did. This is where 85% of your work should be before you even start writing the proof, because now the proof will go together very smoothly. So we're going to start out with line A is parallel to line B. That was given to us. That's kind of important because what does that let us do? That lets us say that angle 1 is congruent to angle 5. And what let us say that? That's our corresponding angles postulate. And you can write it out. If lines are parallel, cut by a transversal, then corresponding angles are congruent. Or if you're lazy like me, you name it, the corresponding angles postulate. Either way is perfectly acceptable. Now, what lets us change congruent to equal measure? This is simply definition of congruence. Congruent angles have equal measures. Again, you can write it out or just write definition of congruence. Then, I'm going to say that angle 5 and angle 8 are supplementary. What lets us do that? That's our linear pair postulate. If you have a linear pair, then they are supplementary. Now that I have said they are supplementary, I can actually write my equation. The measure of angle 5 plus the measure of angle 8 equals 180 degrees. That's simply the definition of supplementary, just a basic definition. Now here is what I really wanted to do in the first place, is substitute angle 1 for angle 5. And what lets me do that is this right here. So I have to make sure I have that step. I've said that the measures of angles 1 and 5 are equal, which means I can now substitute 1 for 5. And now I have the statement, the measure of angle 1 plus the measure of angle 8 equals 180 degrees. This right here lets me say this right here. Angle 1 and angle 8 are supplementary. How come? Simply the definition of supplementary. I said measure of angle 1 plus measure of angle 8 equals 180 degrees. By definition, that is supplementary. So do you see how we logically worked our way through here? This was easy because we spent so much time looking at our diagram, writing down everything we knew, brainstorming, and then the explore section is kind of like an outline. How do I want to go about this? Well, I want to start with angle 1 and 5, and then relate 5 and 8, and that's going to let me relate 1 and 8. So essentially, we said we're going to go 1 and 5 and 8, and that lets us cross out those, which means I'm going to be able to relate angles 1 and 8. Part 2, I will be going through the proofs on the next 2 pages. We will go through those in more detail and do some more of the ideal process for solving proofs. They will be a good resource for you to see how it all works. So let's go enjoy writing proofs.